Okay, so here's quiz number 2. I'm going to walk you through the steps for doing that. So question number 1 says use a graphing utility to solve that equation. You can see the answers already there. All right, so how do we go about doing that? Let me do that on a fresh screen. So quiz number 2, problem 1, x cubed minus 7x plus 1 equals 0. Basically, you let y1 equal the left side on your graphing calculator, x cubed minus 7x plus 1, and let y2 be the right side, y2 equals 0. So I always let y1 be the left side, y2 be the right side on the graphing calculator. And then I'm going to write out the steps. I can't actually show the graphing calculator on this screen, but I sent to all your emails for the online class, I just sent some YouTubes that will show some of the graphing calculator screens. So what you would need to press then, so whoops, getting a little messed up there. So okay, so here's what you would do. So again, y1 equals left side, y2 equals right side. Step 2, your window. Set your window with an x-min of negative 10, x-max of 10, y-min of negative 10, y-max of 10. Step 3, hit the graph button. So when you graph it, then you can see the graph. And so let me do that for you. Okay, so on my screen, here's the type of graph I'm seeing. My graph looks like this. Comes up, goes down through there, down, and back up. So, what am I supposed to find? Well, it's showing that graph. That, of course, is this graph. Where's the other graph? The other graph is 0. So the other graph is this line. Sometimes the right side is not 0. This time the right side is 0. So where do those two graphs equal each other? Here, here, and here. Those are the three x values we need to find, because those are the places where the curvy graph, the x cubed graph, equals 0, is at a height of 0. The second graph is just this line 0. That's the y2, right? This is y1 graph, this is the y2 graph, the 0 line. So I've got to find those 3 points of intersection. How do you find them? You find them one at a time. And so step 4 is you push second calc button, which is above the trace. And when you do that, you move down and choose intersect and hit enter. And then on step 5, it will ask you, you'll have a cursor and you move the cursor. We're going to find this one first. So move the cursor. Oh, I'm sorry. I'm confused. You don't need to move the cursor anywhere. Just hit enter, enter, enter. Just hit enter 3 times. No, I'm sorry. I keep changing my mind. You do have to move the cursor. Move the cursor near first point on the left. So yeah, move the cursor. Move your cursor somewhere like right there, somewhere near. It's going to basically find the nearest one each time. So move it closer to the left intersection point than any of the others, and then just hit enter, enter, enter. And you will find, what is that first one? Negative 2.71. That's right. And then step 6. Now move the cursor near the second point in the middle. This one's on the left, so now move it near that one and hit enter, enter, enter. And I mean, it looks like it's at 0, but it's not. It's x equals, it's 0.14. And for then step 7, do the same thing. Find the third point, move your cursor near it, and the third point is 2.57. And those are the 3 answers that they want. Just list those 3 with a comma on them. Okay, so on number 2, we're supposed to solve. This is no graphing calc. You can use a regular calc, but we're not going to solve this one by graphing. So how do we do it? How do we solve an x squared? What's the plan? Step 1, get a 0. Step 2, try to factor. Or if it doesn't factor, you don't want to factor, you can use negative b plus or minus the square root of b squared minus 4ac all over 2a. So either way will work for solving an x squared. This is what you want to put on your 3x5 card, is that game plan for solving an x squared equation. All right, so how do we do it? Step 1, get a 0. So I got to jump these guys to the other side, so it'll become 2x squared minus 5x minus 25 is 0. Step 2, you can try to factor. I'm not sure how good of a factorer you are. I'm going to just go ahead and use the quadratic formula this time. So the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. This is a. This is b. This is c. So plug them in. What do we get? So it's negative b, and b is itself negative 5. This is a, b, and c. So negative right here on the formula, and then b is negative 5, so it's going to be double negative positive. Plus or minus square root of b squared, negative 5 squared minus 4 times a, which is 2 times c, which is minus 25 all over 2a. So let's simplify that. 2 negatives there. Make that regular 5 plus or minus the square root of 25. Negative and negative make positive. I think that's 200 if you use a calculator there. All over 4. And then that is 5 plus or minus 225 over 4. And that is 5 plus the square root of 225 is, isn't it 15? Let me double check on my calculator. I believe it's 15, yeah. So it's 15 there. 5 plus or minus 15, right? Root 225 became 15. So then you just do those 2 different options. So that's 5 plus 15 over 4 and 5 minus 15 over 4. So that's 20 over 4 or 5. That's minus 10 over 4 or minus 5 halves. Those are the 2 answers from the quadratic formula, like that. You could also factor. I skipped that. If you're a good factorer, you can factor that thing as well. I'm not sure if you remember how to do the factoring, but you could always come to office hours. I'd be glad to show you that. Okay, so now question number 3 in the quiz. It says, is it a function? Is it a function? Just a yes-no question. How do you know? Basically, here's the rules. I don't know if you saw this on the lecture, YouTube lectures or not. If it has y to an even power, y to even like y squared, y to the fourth, y to the sixth, or plus or minus anywhere, then it's not a function. Otherwise, if it doesn't have those, otherwise it is a function. So really simple, just put that in your 3x5 card. Here we have y squared, not a function. Next question, that easy. Okay, so question number 4. They're asking for the domain. How do we do domain? Well, whenever we have a denominator, there's two things we look for. If we have a denominator, say denominators cannot be 0. Or if we have a root and we have something inside a root, we take out the inside and say inside, you've got to be greater than or equal to 0, meaning not negative, because you can't have negative in a root. That's imaginary. And you can't have a denominator being 0, right? Because something like 3 over 0, you know, how many times does 0 go into 3? Infinite. So that's not a number. It's not defined. So we can't have that. All right. So we just look for those trouble spots. Well, here we have it right here. We don't care about that 6 in the top. Doesn't matter at all. Just grab the denominator and say, okay, he's inside of a root. The inside must be greater than or equal to 0. But here's the trick. This is also a denom. This is both inside of a root and it's a denominator. What does it mean to be a denominator? Can't equal 0. So I get rid of that equal 0 part and I just have x minus 7 greater. That's a 7 there. Greater than 0. Add 7. Cancels x greater than 7. How do you write that as interval? 7 with the parenthesis, right? Parenthesis to infinity, because you cannot equal. If that had an equals bar there, it would be a bracket on the 7, wouldn't it? Because then you'd be right on the 7. But we do not have an equals bar. So 7 to infinity, that's the interval. All the numbers bigger than 7, not touching 7. 7.01 would be in there, but not 7 itself. Okay, so here's number 5, and they ask us to find what's called the difference quotient. F of x plus h minus f of x all over h, the difference quotient. This is for sure going to be on exam number 1, the difference quotient. How does it work? Well, first off, let's say you need f of x plus h. So that means, if this helps, let me come back up here for a minute. Let me show you something. The x's in a function, they're like holes in a toaster. So if that helps. So basically when I plug in, like what's the first part want me to plug in? X plus h. When I plug in x plus h, it goes right here. So 2x plus h squared minus 5x plus h plus 8. That right there, oops, I didn't go quite far enough. That right there is f of x plus h minus f of x. 2x squared minus 5x plus 8. This is f of x all over h. Okay, so this part here, I'm going to work it out. It's 2, and you got to write x plus h. In fact, you know what? Let me, I'm going to need a little more room, I just realized. So let me bring it over here, and I'll keep it the same color. It's going to be 2x plus h, x plus h. So I'm going to go ahead and square that. I just don't have room for everything. So if you square x plus h times x plus h, remember a 2 on a parenthesis means 2 of those, 2 parentheses. So if you do the 2 parentheses and you FOIL it out, it's going to be x squared plus 2xh plus h squared. And the 2 is still in the front, minus, and then the 5 is going to distribute through, minus 5x minus 5h plus 8, and then this minus sign is going to go boom, 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 changing all the signs. Minus 2x squared plus 5x minus 8 all over h. Okay, now I've got to distribute this 2. Boom, boom, boom. and I get 2x squared plus 4xh plus 2h squared, and then minus 5x minus 5h plus 8, and then the minus 2x squared plus 5x minus 8 all over h. And now let's cancel. What will happen on these difference quotient problems whenever you're doing this thing, which will for sure be on exam number 1, is the non-h terms always cancel. So 2x squared and minus 2x squared. 5x, those guys cancel. See, all the ones that don't have h's have canceled out. That always happens. It's a good way to make sure you didn't mess up. The non-h terms always cancel. So what are we left with? Just 4xh plus 2h squared minus 5h. That's it, huh? Over h. Now, what do you do for canceling? Well, what you can do is factor an h out of the top here. 4x plus 2h minus 5 over h, and then these cancel. So our final answer then is, whoops, I'm getting a little scribbly there. 4x plus 2h minus 5. Okay, let's go on to number 6. Number 6 gives these points and asks if it's a function or not. Well, remember, a function has, for a function, I should say it this way, for a function, every x has only one y. So if you could write it vertically, maybe that would help. I'll write x and y. So we got 5, 9, 7 minus 4, negative 1, negative 8, and 5, 1. So, is that a function? No. As you can see, the answer is already there, because the x of 5 goes with 9, and it also goes with 1. That's the same x going with two different y's. So that's why it's not a function. Every x can only go with one y. All right, what about the next one? Determine this graph. What's its domain and range? First off, is it the graph of a function? So, yes, because it passes the vertical line test. Remember that? Every vertical line hits only one point. Right? Every perfectly vertical line would hit only one point on the graph. If a vertical line ever hits 2 points, then that would break it. That's the same thing as every x having only one y. Right? If you ever had a graph, say like this, and you hit 2 points, then that would be an x value, like, I don't know, maybe that's over 2, up 3 and over 2, down 3. That's the same x, right? Same over amount hitting two different y's. A vertical line can't hit 2 points. That would be not a function. That's the same as that. So this one's good. This one's a function. Every x hits only one y. Right there. Okay. Step 2. What's the domain? The domain, whenever we do domain on a graph, it's left edge, comma, right edge. What's the left edge? Looks like it. This branch here goes up and left forever, so it's negative infinity. What's the right edge? 0. See how it gets closer and closer to 0, but it'll never touch it? So that's why it's negative infinity to 0, but it doesn't touch it. So the parenthesis on the 0 there doesn't quite touch it. And the range is the up and the down. Range is bottom. So just like domain is left, right, range is bottom, top. So this graph goes down forever to negative infinity, up forever to positive infinity. That's the range. Okay, they also ask if this graph has any intercepts. Let me go to a fresh screen here. Does this graph have any intercepts? That's question B. So I'll just answer it right here. Intercepts, yeah, right here. Intercepts are places where the graph hits the grid line. So that's the point, what, back 1, up 0. That's the intercept. Final, that's question B there. Final question C, is there any symmetry? No, this graph is not symmetrical with x-axis, y-axis, or anything. None. No symmetry. It's not the same. If it was over here also, then it would be the same on the two sides of the y-axis, and there's other kinds of symmetry. It has none. Okay, final question, number 8, has a lot of parts to it on the quiz here. They give me this function. They say, is the point 2,5 on the graph? How do we figure that out? You can see the answer is yes over here. How do we know that? So for part A, we take f of x equals 2x squared minus x minus 1. Remember, the f is the y. This is y over here. So if they're asking about the point 2, 5, they're saying when x is 2 and y is 5, does that work? So we put in y 5, x 2. Does this thing work? Is it true? This would be 2 times 4, 8 minus 2 minus 1. Yeah, 5 equals 5. Yes. So that's why it's yes. The point 2,5 is on the graph because it makes the equation true. Part B, is x equals negative 2? If x is negative 2, what is f? So that's just plugging in x is negative 2. To the function. So f of negative 2, plug in negative 2. What do you get? 2 times 4, 8, plus 2 minus 1, 9. And that's what they got. And then they say, what point is that? Well, that's going to be the point negative 2, 9, because the x value negative 2 led to the y value 9. Negative 2, 9 is the xy point. All right, let's go to part C. I'll move it over here. Part C asks the question, if f of x is negative 1, what is x? Now f, that's the same as y. So for part C, I'm taking this equation. F of x is 2x squared minus x minus 1. And I'm letting the f of x, the whole f of x, is negative 1. Right? I'm not just plugging negative 1 in for x. They didn't say x is negative 1, right? Look here. It says the whole f of x is replaced by negative 1. So I just replaced the whole left side by negative 1. And so I have an x squared equation to solve. How do I solve that x squared equation? Well, we just did it on one of the earlier quiz questions. Let me bring it to a fresh screen. So for part C now, we have negative 1 equals 2x squared minus x minus 1. How do we solve x squared? Step 1, get a 0. Step 2, you can try to factor if you're a good factorer. Step 3, or you can use the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. Right? So let's first off get a 0. So that would be add 1 to both sides. That's 0. Is 2x squared minus x. These are gone, these are gone. So step 1, get a 0. Step 2, try to factor. Now this one's easy to factor, so I don't have to use the quad. How can I factor that? What's the GCF? What do they have in common? X leaves 2x plus 1, right? If I multiply that, it'd go back to 2x squared. If I multiply that, it'd go back to x. So that's right factorization. That's step 2. And then what do you do from there? You set each part equal to 0. So the x alone, this part, is 0. And then this part, 2x minus 1 is 0. Why do we do that? Well, because if two things are multiplying to equal 0, if two things times to be 0, either one could be 0 to make them multiply to be 0. So that one's done. This other one, I've got to add 1. 2x is 1 divided by 2. X is a half. So my answers are 0 and a half on part C. Now it also asks what are the points on the graph this means. So remember, this was the y value. Whoops, kind of messing that up there. This was f of x or y. So that means x equals 0 goes with y value negative 1. And x equals a half also goes with y value negative 1. These are the 2 points, right? Because they're both x values. They're both here and here. And they both came from plugging in f of x right back here. See how we let f of x be negative 1? Negative 1 is f of x. That's y. Remember, function values, g, f of x, g of x, h of x, those are y values. So those are both y values of negative 1. Those are both y values of negative 1 that led to the x values of 0 and a half. So those are the 2 points. Let's go to part D. And then part D asks, what is the domain of the function? So how do we do domain? Well, remember, for domain, we look for two trouble spots. Number one, denominators cannot be 0. And number two, if you have a square root, something on the inside must be greater than or equal to 0, not negative. Well, this function here doesn't have denominators, doesn't have denominators or roots, so he doesn't have any problems. So his domain, man, I'm just really scribbling here. His domain is negative infinity to infinity, which is what they list here. Let's go to part E, list the x-intercepts. So the x-intercepts of it. How do you find x-intercepts? To find, on part E here, to find x-intercepts, you've got to set y equal to 0. You always set the opposite letter equal to 0, because that's what it means to be an x-intercept. Think about it. If you have some kind of graph that has a couple x-intercepts, that means this point is y value is 0. It's up 0, isn't it? And this point also has got to be up 0. I don't know what their x values are, but their y values are up 0. At an x-intercept, your y is 0, isn't it? That's just what it means to be an x-intercept. So that's what you do with the equation. Whenever you want to find an x-intercept, you just make y 0. So take that equation. F of x is 2x squared minus x minus 1. And put in y 0. Where's y? It's f of x. Again, function values are y values. And so now we have to solve that equation. How do we solve that equation? Well, remember we talked about solving x squared equation. Step 1, get a 0. We've got that. Step 2, in fact, actually, we better go to a fresh screen here. So for part E, now we're trying to solve 2x squared minus x minus 1. Yeah. And so for x squared, I'm going to go ahead and use the quadratic formula, because this one's not easy to factor. You could factor it if you're a good factor. I'm just going to use the quad, negative b plus or minus the square root of b squared minus 4ac all over 2a. This is a. B is negative 1. C is also negative 1. So here we go. Negative b, negative 1 plus or minus the square root of b squared minus 4 times a times c all over 2a. So let's simplify that. That's a negative 1. That's regular 1 plus or minus the square root of this is 1 right here. Minus and minus is plus 8 over 4. And this equals 1 plus or minus the root of 9 over 4. That equals 1 plus or minus 3, right? Because root of 9 is 3. And so it's what? 1 plus 3 over 4 or 1 minus 3 over 4. That's 4 over 4 or 1. This is minus 2 over 4 or minus a half. Those are my two x answers. What else do they want? Those are my x answers on that. And so that's all they want for that. Those are the two answers. Finally, part F. Part F says find the y-intercepts. The y-intercepts. So, and what was the original function? F of x equals 2x squared minus x minus 1. So to find y, how do we find y-intercepts? Well, remember what we were saying. Think about a y-intercept. If a graph hits the y-axis and a y-intercept, that means his x-coordinate is 0. I don't know what his y is, but this point here has an x-coordinate of 0. That means set x to 0. You see how we always, for intercepts, we always set the opposite letter to 0. So for, coming back over here, for an x-intercept, we make y 0. And for a y-intercept, we make x 0. So plug in 0, plug in 0. And f, that's y, will equal 2 times 0 squared minus 0 minus 1. Y will equal negative 1. That's the y-intercept. So there is the quiz.